Last time, we talked about what happens to those angle pair relationships when those two lines become parallel. So, we're going to be doing proofs over this now. So, proving that alternate interior angles are congruent, proving that corresponding angles are congruent, and so on. So as a refresh, we want to figure out what type of postulate or theorem, that's our corresponding angles, the alternate interior, alternate exterior, or same side, is being shown. So as a recap, we did highlight our zigzag. And we know same color means same value, so they are congruent. Different colors add to 180. So for this first one, angle 1 is congruent to angle 5. So angle 1 congruent to angle 5. Those are in the same location, so this is our corresponding angles. Second one says angle 4 and angle 6 are supplementary. Angle 4, angle 6. That relationship is our same side interior. Next is angle 4 is congruent to angle 5. Well, they're both inside, but they're on opposite sides of that transversal. So that is our alternate interior angles. The last one said 2 and 7. 2 and 7 are both outside of our parallel lines, but different sides of that transversal. So this is our alternate exterior angles. So we have a few more reasons for proofs now. So it says you can only use the following new reasons if and only if they tell you the lines are parallel. So if you remember, when we do proofs, we write down one given. Well, now, if that given says parallel, it unlocks these 4 for use. If we do not say they're parallel, we can't use those 4. However, we will always be able to use the following reasons, even if the lines don't say parallel. So we'll always be able to use the vertical angles congruence theorem. So vertical angles are congruent. Definition of linear pair, the linear pair postulate, and the definition of supplementary. We'll always be able to use them. So let's look at our first proof. Now, before we even look at it, I have a note on here for us. It says proof number 1, alternate exterior angle theorem. In other words, we're proving alternate exterior angles are congruent. So just like when we talked about the vertical angle proof, we could not use vertical angles in its own proof. It's just like trying to use a word in its own definition. Does not make sense, cannot happen. So we're going to have to use anything but alternate exterior angles. So let's start off. Our first statement we know will forever be our given, or in this case Q is parallel to R. Reason is given. Well, we said they're parallel, so that unlocks those 4 new reasons. So what we can do is look at our diagram and see what relationships we do see. Well, I see angle 1 is right across from angle 2. So angle 1 has to be congruent to angle 2 because they're vertical angles. Looking back at our diagram, I see 1 and 3 are both outside of the parallel lines, but opposite side of our transversal. So that has to be congruent. They're alternate exterior angles. So always try to find at least 2 relationships. So angle 1 congruent to angle 3 because of the alternate exterior. Now to finish off the proof, now that we have 2 statements, see, is there something that we could combine? Can we combine those 2 statements? Well, looking at it, they both have the measure of angle 1, so yes, we can. So we can say angle 2 is congruent to angle 3. And remember, whenever we combine 2 or more statements, that will either be substitution or transitive. We do not care which one you use. I will say it's substitution. And this is a property of congruence because it has a congruent symbol. If it had an equal symbol, it would be a property of equality. Let's look at the next proof. Just like the first one, proof number 2 says same side interior angles. So we're trying to prove same side interior angles are congruent. So we can't use that as a reason. So we know how we're going to start. We always start with our first given. In this case, M is parallel to N. Okay. So this one brings in a new type of dilemma. We have a lot of options in this picture. So because we have so many options, let's look at what we're trying to do. That might help us narrow down what to write. Well, we're trying to prove angle 3 and angle 5 are supplementary. So if we're trying to prove they're supplementary, we need to deal with another supplementary relationship then. Also, it already says angle 3 and angle 5, so I know I have to deal with angle 3 and angle 5. So I'm going to mark those. Now I get to choose any other angle as long as that angle is supplementary to either angle 3 or angle 5. Once again, it has to be supplementary because at the end of the day, we're trying to prove 3 and 5 are supplementary. If it was 3 and 5 are congruent, we'd look for another congruent statement. So I could say, I want to deal with angle 4. Those are the 3 angles then we're going to deal with. We're going to ignore the others. So there are 2 relationships between angle 3 and 4 or angle 4 and 5 that we can say. So let's deal with angle 3 and angle 4 first. So I know they're a linear pair. They're right next to each other. So I will say angle 3 and angle 4 are supplementary. I know they're supplementary because they're a linear pair. Now, check. Does our statement have a vocab word in it? In this case, it does. Supplementary. Well, supplementary means they add to 180 degrees. So I know that the measure of angle 3 plus the measure of angle 4 equals 180. Once again, the vocab word that we dealt with is supplementary. So that is our reason then. Definition of supplementary. So we're going to check. Does our statement now have a vocab word in it still? It doesn't. So we're going to put a mark off to the side. Because we left off here, we're stuck here, there's nothing else to do here. So let's see another relationship. So we already said 3 and 4. Well, what's the relationship between angle 4 and angle 5? Well, angle 4 and angle 5 are alternate interior angles, and those are congruent. So in other words, we know angle 3 is congruent, not angle 3, angle 4 is congruent to angle 5 because they are alternate interior angles. Now, we don't have a vocab word, but if we look at where we left off on our first statement, we have an equal sign. And in this statement, we have a congruent sign. So we can't really do anything with those two, but we can always change a congruent sign to an equal. I can do measure of angle 4 equals the measure of angle 5. And remember, whenever we go from congruent to an equal or an equal to a congruent, that is definition of congruent. So we are stuck here, so I'm going to put a mark off to the side. There's no vocab, we already have an equal, awesome. Can we combine where we left off? Yeah, they both have measure of angle 4, measure of angle 4. So we can replace measure of angle 4 with a measure of angle 5. So measure of angle 3 plus the measure of angle 5 equals 180. And remember, when we combine two or more statements, that is our substitution or transitive properties. But because we have an equal sign in this one, it would be a property of equality. So we technically have a vocab word here. We have two angles that add up to equal 180 degrees. Well, whenever two angles add up to 180 degrees, that means they are supplementary. So I can say angle 3 and angle 5 are supplementary. That would be definition of supplementary. let's look at proof 3. Proof 3 does not say anything about proving one of those theorems. So we're going to start off normally. We would possibly have access to everything. So let's write down our first given. First given, P, upside down capital T, Q. So remember that upside down capital T means perpendicular. So we're going to look at our first given. Do we have a vocab word? Oh, actually, yeah, perpendicular. Well, we need to remember what perpendicular means. Perpendicular means two lines or line segments that intersect each other and make a right angle. So because we said these two lines are perpendicular, I know that angle 1 is a right angle. So this would be our definition of perpendicular. Now, do we have a vocab word still? Yes, we do. Our vocab word is now a right angle. Now, right angle we know means that it's equal to 90 degrees. So measure angle 1 has to equal 90. Because that is the definition of a right angle. Do you have any more vocab words? Well, no. So I'm going to put a mark off to the side. Just as a reminder that we left off here, we probably have to do something with this later. Well, we have a second given. Second given says Q is parallel to R. Because we said these two lines are parallel, that unlocked our 4 options. So I want to look at my diagram and see what relationships we have. Well, we only have 2 numbers, and the relationship between those two would have to be corresponding angles. They're in the same location. So I can say angle 1 is congruent to angle 2 because of corresponding angles. Well, looking at where we left off on the purple, you have an equal. So that does tell me that we have to have just equals for now. And we're stuck at a congruent. So we will have to switch. So measure of angle 1 equals measure of angle 2. Remember, that is our definition of congruence. Well, we have an equal, we have no more vocab, so I'm going to put a mark off to the side. Well, just glancing, I'm done with givens, and I have 2 marks. So I want to see if I can combine these 2 left off points, which I can. They both have measure of angle 1, so that means the measure of angle 2 has to equal 90. That is our substitution property of equality or transitive property of equality. Well, I have an angle equal to 90 degrees. That is a special angle. We know that that angle is a right angle then. So angle 2 has to be a right angle. Because that's what a right angle means, so definition of a right angle. Well, and if we have two lines that make a right angle, that tells us that those lines are perpendicular. So P has to be perpendicular with R. Definition of perpendicular. So in reality, this proof is a 9-step proof. However, once we write our first given, we'll deal with vocab until we can. Then we write our second given, deal with vocab until we can. Then most likely combine things and deal with more vocab. Geometry is vocab heavy. Look at your last proof of the day. Once again, not trying to prove any special relationship, so I will write our first given. Q is parallel to R. And I will even emphasize which two we're talking about. Q and R. So that unlocks relationships. So looking at our diagram then, I can say, well, the only angle on line R is 3. So I know we have to deal with angle 3. And I know at the end, according to our proof, we have to deal with angle 1. But we have multiple options now. So we're going to choose one. And it does not really matter which. So I can say 1 and 2. 1 and 2 are corresponding angles. So angle 1 has to be congruent to angle 2. Not angle 3 and angle 2, my bad. And there's not much else that we can say about angle 3 then. So I put a mark. I'll write my x given. P is parallel to T. So now I'm talking about the other two lines. So is there a relationship between the two that we were using now and the 1? Well, here's our parallel lines for that one. 2 and 1 would be congruent because they're alternate exterior angles. So angle 2 congruent to angle 1. Alternate exterior angles. So we stated our relationship. Put a mark. Look at our two marks. Can we combine things? We most certainly can. So I can say now, angle 1 congruent to angle 3. We combine things, so that is our substitution property of congruence.